methods in physics. So once again, good evening to all the respected dignitaries, resource person, faculty members, research scholars, and enthusiastic participants. It's really giving me a great pleasure to welcome you all in today's final technical session. Over the past 4 days, we have had the opportunity to explore several exciting areas in computational physics, from physics-informed neural networks, computational luminescence, optical trapping, and density functional theory. Each session has provided valuable insights into how computational tools are transforming modern scientific research. Today, we conclude the technical session of this workshop with an equally important and widely used approach, Monte Carlo methods in physics. What makes today's session even more special is that the resource person of this final session is none other than our convener of this workshop, Dr. Bhakti Rajvaidya, who has been instrumental in successfully coordinating and moving ahead with this entire workshop. So before we begin the session, it is my privilege to introduce the chairperson for today's session, Dr. Nilesh Ogemoge. Yes. So Dr. Ogemoge, he is an assistant professor in the Department of Physics at Anand Niketan College, Varora, with extensive involvement in undergraduate, postgraduate, and PhD programs. And he holds dual degrees, PhD in physics and PhD in management, reflecting interdisciplinary expertise in both scientific research and organizational studies. He has 17 years of academic experience, and he has significantly contributed to teaching, research, being research supervisor and academic administrator. His research specialization lies in material science, particularly in luminescent materials, phosphors, and optical applications. He currently serves as IQAC coordinator under NAC, and he is recognized PhD research supervisor and postgraduate teacher at Gondwana University. He has numerous research papers to his credit in international journals, in particularly in luminescence, spectroscopy, and optoelectronic materials. He has authored and edited several academic books and book chapters, and he has published in elsewhere, CRC Press and Himalaya Publishing House. He actively contribute to academic leadership and professional development, and he delivers invited talks, and also he takes training sessions on research methodology, IPR, innovation, and soft skills. And he is associated with multiple professional societies and academic bodies, and we are looking forward that he will join AACST also. He will also get associated with Association of All Computer Science Teachers. And with that invitation, I hand over this stage to Dr. Nilesh S. Ogemoge to please open the session as well as introduce our resource person for today, Dr. Bhakti Patankar. Over to you, Dr. Nilesh Ogemoge, sir, the chairperson of today's session. Over to you, sir.
Thank you, Dr. Abha ma'am, for a nice introduction of mine, and thanks, Dr. Bhakti ma'am, Dr. Abha ma'am, for giving me an opportunity to be here to chair this particular eminent session. So it is my privilege to introduce the speaker for this particular session, Dr. Bhakti Patankar Rajvaidya. She is like I'm very happy to share over here. She's my senior, and now she is working as a international relationship officers at and assistant professor in physics at GH Raisoni College of Engineering, Nagpur. It is one of the prestigious institution among the Nagpur as an engineering college. Her educational attainments, she holds a PhD in physics from RTM Nagpur University and a recognized scholar having achieved status of college topper and university rank 3 during her Master of Science degree. Just about her extensive experience, she has teaching experience of 18 years and again having research experience of 10 plus years. So her research expertise include the computational and mathematical modeling with particular interest in fractals and theoretical physics. So she is a prolific author. She is again, in addition to prolific author, she is organizing many workshops. I was participant for her last workshop. Enthusiastically, she is organizing many workshops, conducting many trainings, and always just I can say she is a lifelong learner also. In addition to that, she has authored 8 books and numerous book chapters, published more than 20 plus research articles in SCI and Scopus Index journals, along with one patent and 7 copyrights to her credit. In terms of the award which she has received, she won the prestigious AICTE Lilavati Award 2020 in the self-defense category. In addition to that, she has received multiple awards for her best research papers during numerous international conferences. And in terms of, as I said, she's an active learner. So she has done numerous number of courses from NPTEL and again under the banner of NPTEL, she is recognized as NPTEL Domain Scholar and Star. So that is a very prestigious one in terms of the NPTEL courses. Then again, like new 25 women's chess winner, she's a chess champion. That just I came to know very first time. So it's again the great things about ma'am, and she has secured a grant of numerous lakhs, and she is connected with numerous number of professional bodies like this Computer Association of All India Computer Science Teachers, IAPT. She is actively conducting various workshops under IAPT, as I am also one of the member of IAPT. So, and ma'am has visited the countries like Singapore, Thailand, Indonesia, Nepal for academic purposes. So, with this note, with this brief introduction, I request Dr. Bhakti Patankar Rajvaidya for delivering her talk in today's evening. Thank you. Thank you. And now I say ma'am can start her session. Thank you.
Thank you so much, sir. That was very kind of you to say those words. So it's uh, really actually embarrassing to hear so many things about you when you feel that you are still in a learning phase from the towering personalities like you. But still, so without wasting much more of the time, let us start with the today's topic. So let me start sharing my PPT of today's presentation with you, which is the Monte Carlo. So I hope you are able to see the presentation slide, and here I run it in the slideshow mode. So I hope you are able to
Yes,
see the
ma'am. Yes,
presentation.
yes.
Yes.
Yeah, it's visible and you are audible too.
Yeah,
Yeah.
fine. So let us begin with the uh, fifth day with a very interesting topic, Monte Carlo methods in physics. I have heard this topic. I have might have used it somewhere during my PhD research journey for doing some theoretical or mathematical modeling calculations and all. But when Abha ma'am proposed me this topic, then I got, we can say, a trigger that I want to learn this topic a little bit more. And then for the very first time, I had gone through the topic, through the details of the topics. And today I'm going to just show you what I have learned through the different resources available. And I want you to also understand in the maybe same way, maybe a little bit funnier way, or whatever the way you want. So let me begin my today's presentation, Monte Carlo Methods in Physics. I'm Dr. Bhakti Rajvaidya from GH Rasani College of Engineering, Nagpur. So Monte Carlo, may this topic take you to the history, brief history of the Monte Carlo, to the randomness, to the discussions of probability, statistical predictions. Then we may have some examples of sampling. We may have some examples of finding out some probabilistic problems. And then at the end, we may have some real world applications of the Monte Carlo. So this is the content, would be content of my presentation. May not be exactly so, but this is. So now let us dig into the history of Monte Carlo. Where did it get its name? So many of the phenomena got their name mainly due to the discovery by some scientist, and that scientist owns the name most of the time. But please, Monte Carlo was not a scientist. There is a good story behind it. So let us go through the story first. So it was the time during World War II when the scientists were very stuck in one problem, we can say. The problem was of neutron diffusion. The team of Oppenheimer and others were working on the atomic bomb concept during World War II. And then they were stuck with some neutron diffusion probabilistic problem. So one of the scientists who was involved in that problem was Stanislaw Ulam. Okay, he got sick, and during his recovery period, instead of wasting his time or relaxing, he started playing solitaire game. Okay, the simple play card games, solitaire. So then he just out of curiosity tried to found out how many times he can win the game. So instead of calculating it probabilistically using some mathematical formula, he just simply played that game again and again and again and again and so many times, maybe thousands of the times. And then he just noted down how many times he won. And then it was some shocking revelation came to his mind. Then he discussed this revelation with his one of the colleagues, and the powerful mathematician of that time, physicist John von Neumann, who immediately recognized that such kind of multiple performance of some sort of problems can solve probabilities a value of that problem. And at that time, computers were invented. So he transformed that multiple iterations into computers. And he came to the result that computers could perform thousands of millions of random trials much faster than humans, and you can get a probabilistic value maybe more accurately. Okay. So what is this all about? Is nothing but suppose you have gone to a casino and then you are playing a game of some prediction that you have predicted that the dice will roll and it will give you your value 6, and you put money on that, and then there are chances of you winning. That 6 number is 1 by 6, we know, because dice has 6 faces, and then your chances of winning become 100 by 6, that is 16% or something. Okay, so if you play the game only one times, there are highly likely the chances that all 5 other faces may turn up and you will lose the game. So this probability game is just like the game of casino. And hence the the duo of the scientists, they gave this probabilistic version of simulating the game again and again and again, and then obtaining the last answer as the final probability. And they gave this simulation method as Monte Carlo simulation. The name was given in the name of famous casino Monte Carlo, located in the city of Monte Carlo, Monaco. Okay, so this was the brief history. Now let us take the history away and come into the reality. In reality, we have two sorts of problems. One is deterministic and one is probabilistic. Now, what is deterministic system? A deterministic system is one in which the outcome is completely determined by the initial conditions or the inputs. Whatever the inputs you are feeding in, that inputs, then the process, and you are certainly going to get some sort of output. Okay. There is no randomness involved. If you perform the experiment, you will get the same output. If I perform the experiment, I will get the same output. If someone else in some other country performs the experiment, he will get the same output. So if you repeat the experiment with the same amount of input, the same results you are going to get. So you can say the results are predictable. Okay. So that is the exact mathematical equation governing system, where you can completely design the system using some simple mathematical equation. Like simple example, y equal to 2x plus 3 is a simple mathematical equation. When x equal to 5, So if I solve this equation using computer, I will get 13. If I solve this equation mathematically using simple scrap, if I ask a student of some 6th or 7th standard to solve this, he will also get 13. So whosoever maybe the solve, whatever maybe the method, the answer is going to be 13. Every time you are calculating, it is 13. So that is the system which we call a deterministic system. Now there are the systems which are not deterministic, where you cannot predict. Now these systems comes under probabilistic heading. Like if you have the inputs, but you cannot predict the results because there are some factors involved which are called randomness or uncertainty. Okay, so the exact outcome or exact output may not be predicted, and maybe this happen that each time if the system is repeated, the output or the outcome may be different. So this is where the randomness or the probabilistic concept evolve. Okay. Now, this such kind of system requires large number of trials to give a statistical pattern. So this kind of physics is generally dealt by the statistical physics branch. Okay. So for example, radioactive decay, we cannot predict which atom will get decayed out of the total number of atoms in a radioactive element. Then the weather predictions, these are probabilistic values. Although we try to calculate the weathers by certain parameters like pressure, temperature, humidity, and all that, still the weather remains unpredicted for most of its situation. Then stock market fluctuations. This is the most, we can say, wanted game in the market. Anyone wants to learn. More of the mathematical modeling are being done just to decode this game, stock market fluctuations or predictions. Still, we are not able to do successfully. Then Monte Carlo simulations, one of such decoding game which predicts mostly the uncertainty or randomness. And then simply tossing a coin. Okay, what are these big names are there, and what is this tossing a coin is doing over here? So let us go see what this tossing a coin does here. So you simply know a coin game. Okay, when we have a game of cricket, we toss a coin and we decide, I call heads, you call tail, and if I got heads in on my coin, I win, you lose. So probability for tossing one single coin is, mine is 100%, yours is 0, right? If I toss the coin 2 times, what will happen? I will win one time, you will win one time. So probability is 50-50. Or I will win both the times, you will win 0 time. So probability is again 100. When you ask a learner of mathematics, maybe graduate learner, that what is the probability of tossing a coin, he will say 50%. Okay. Now where that 50% came? So let us toss a coin and get the probability exactly done. Okay, so if you have a coin nearby you, you may take the coin and simply toss it. Or otherwise, don't worry, just sit back, relax, and I will get a coin for you. So just click over here. And now, I don't think you are able to see the screen. So I will directly share my screen now so that you will be able to see where I'm going to click. So I hope you are able to see the screen.
Yes, ma'am.
Yes. So this is a simple simulation for tossing a coin. Okay. So if you want to have the virtual tossing of the coin, if you are playing virtually, so you may use this simulation. Okay. No worries. I'm going to share the PPTs with you so that you can get all the links there. So suppose I have this coin over here, which is written right now heads. So right now I have 0 heads, 0 tails, and I will flip the coin using this button. And now tell me the probability value. So if I note it down, so if I flip the coin 4 times, ideally, I should get 2 times head, 2 times tail, right? Means both the probabilities should be 50-50. So let us flip the coin. So this is one time I have flipped the coin with sound effect, of course. I got 1 head. Again, I am flipping the coin. I got 2 heads. Right now, the probability is 100 and 0. I'm flipping the coin 3rd time. Oh, I got 3 heads. And now I am flipping the coin 4th time. Oh, I got all the heads. You lose. Now, what does this mean? There is no concept of 50-50. So, whatever being taught to us, that probability of tossing a coin is always 50%? No? Oh, that sounds a little bit weird. Okay, so let us get back to the presentation. So, probability of tossing a coin doesn't come out to be 50-50. I could toss the coin 4 times. I got 4 heads. I won all the 4 times. I'm so lucky. Okay, let's move further. We have so many games over here. So, now, let us toss the coin in the game of cricket. Now, what happens in tossing the coin in the game of cricket? Okay, I will come back to this slide later, maybe. Let us do the game of rolling the dice first. Okay, let us take the examples that why they are not getting fitted in the probabilistic value. So, another example is rolling the dice. Now, rolling the dice, so you know the famous, we can say, the story of Mahabharata, where there were 100 of Kauravas and 5 Pandavas. They played the game of Dyut, and then they had some dice, and then they rolled the dice, and then they lose. Okay. So let us see the rolling the dice game. So let us click on this dice, and we can go to the screen of dice roller. This is one of the application given by the calculator, simple calculator app of your mobile phones. So you can select number of dice. So I'm selecting number of dice as 1. Okay. Now a dice has 6 faces. Okay. So I have 1, 2, 3, 4, 5 or 6 appearing on my screen. If I roll the dice, sorry, for 6 times, I should get exactly 1 times 1, 1 times 2, 1 times 3, 1 times 4, 1 times 5, and 1 times 6. So all my 6 faces should appear 1 times ideally. Okay. So probability of getting one face will be 1 by 6 of 100%. So I can say 16%, around 16.6% should be the probability of getting each face. So now I am going to roll this dice in front of you 6 times. So let us roll it first time. I got a 2, so I will take a 2. Let us roll it second time. I got a 4. I take a 4. Third time, I got a 5. Okay. So good so far. Okay, I got a 1. Okay, I got a 1 again. Now this was my 5th time, and now just 1 remain. So I got 6. So there was a number 3 which did not appear at all. So the probability of getting 3 out of these 6 chances turn out to be 0, and 1 appeared twice. So probability turned out to be 16 into 2, 32% of the probability. So is it not correct that we have been taught that rolling a dice will be the 1/6 of the probability that you are going to get one face? Oh, so are we not being taught correctly that rolling a dice and tossing a coin is correct version of teaching? So where did that 50% or 16% probability appear? So let us take help of a scientist. And what the scientist has made for us is this simple Google sheet, which I'm going to open, Monte Carlo simulations. Okay. So this Google sheet I'm going to share with you, no doubt. So Monte Carlo simulations for different concepts like coin probability, rolling a dice, pi estimation. What is pi estimation? We are going to see further. So coin probability. So here I have simply added some formula that I will call heads as 1, tails as 0. I will generate the random numbers between 0 and 1. Okay. So probability of I win and probability of you win. So if the number appears 1, then you wins because you are calling head, suppose. If the number appears 0, then I win. So I will be counting here the number of ones in your probability. I will be counting here the number of zeros in my probability. Right? So now let us count, sorry, the number of ones in my probability if 1 is head towards me. Okay. So now let us see what is the probability of heads when I am taking heads is winning. And let us run the coin for only 10 times. So I am deleting out all these chances. So delete this out. This is a simple Excel way of doing Monte Carlo simulation. So I'm doing the 10 iterations. So these are my numbers. So I may reload the sheet now simply. So these are the 10 numbers and these are the chances of winning. 60% of the chances I'll be winning, 40% of the chances you will be winning, right? So this is not 50-50 yet as the probability game should be. Now let us increase the number of iterations. So if I increase more, so chances become 35-65. Let us increase little bit more. So let us select and just drag the formula. So let us make it up to maybe some random number 500. So I drag it up to 500. Something going near 500. So these are the number of iterations on this side. So suppose 500 times I am dragging it out, coming back. So 50 to 48 it is showing right now. If I reload the sheet, let us see what probability comes. So after getting it's 55, 45. So still we are nearly 50. It is not getting exactly or completely 50. This I have taken complete the value of B's and B's counting heads. Okay. So many times I am reloading the sheet. Each time the random numbers are generated. And yes, sometimes you may get the probability 50-50. Like, so this probability number will approach 50 when you have multiple number of runs, trials going on. So that's how this probability 50% of the chance that when you toss a coin, you win came into picture. And now let us go back to that slide, which I told you that I will take it later. The slide of this Indian toss statistics in one day international cricket. So if I take a statistical value that India has played 1,050 times ODIs till now, and if I consider the number of times the India has won the toss is nearly 520 to 540, somewhere between 520 to 540. Exact statistics is not available. And losing chances are 510 to 530. So if I count this as a fraction or probability value, it is number of time the India won the toss was 49 to 51%. Means on an average, I can say 50%, right? So India has played a lot of match, maybe a sample of 1,000 was available. So the probability came out to be 50%. Well, let us see the newly joined one-day international cricket team, Japan, who has just joined in 2024 and so far has played the match only 3 in number. Okay, so Japan has undergone 3 one-day internationals. So here, the Japan has faced 3 tossed till now. Out of 3, Japan has won 1 toss, lost 2 times. So the winning percentage is 33%. Okay, so if you are tossing a coin, you should be always 50% probable to win or lose. So that comes only when you have large number of data. So this is called the law of large numbers. The probabilistic value or the statistical value will only approach when you will have large data samples to be tested. Okay, so let us move ahead in the rolling dice game. So coming back to our, we can say the Excel sheet. So rolling of dice, I have this Excel sheet. Simple formula. Again, I have selected random numbers between 1 and 6. And then I have calculated the probability of getting 1, probability of getting 2. So I have just counted number of 1s, number of 2s, number of 3s, 6, 5s and all. Okay. So probability should be always 100%. So 100% is getting divided over here. So each time it should get in the correct number. So the simulation which I have shown, I have run the dice only 6 times. So I can show the simulation in this Excel by deleting the remaining numbers like this. Suppose I delete all the iterations. Suppose all 1,000 iterations I deleted. And now I will show you if I roll the dice only 6 times. So let us reload the sheet. So after reloading the sheet, I have rolled the dice only 6 times. So the probability of getting, okay, this time I got the probability completely correct. Now let us roll it once again. Okay. Now this time probability A got more 33%, B got much more, then 3 got only 16 times, 4 was not appeared, 5 not appeared, 6 not appeared. So this is not proper distribution of probability. So that's why if I run this for so many of the times, like suppose 200 times, let us stop it at 200. So at 200 times, what happens to the probability calculation? So let's go up, reload the sheet. So if I reload this, so let it get stable. Okay, so now this is 16, 15.5, 18.5, 17, 16, 17. Now it is approaching exactness of the probability value 16.7. So if I keep on increasing the number of trials, like from 200, if I go to some thousands of trials, I may get a proper probabilistic distribution 1 by 6 of 100, which is 16.7%. So if I reload the sheet, let us say the probability distribution came out to be 17.1, 16.3, 16.3, 16.3, 16.7, 17.2. So moreover, it is exact probabilistic distribution. So to get exact answer of probabilistic values or to establish some statistical rule, you need to have large samples. You need to iterate the program, or you need to iterate your equation so many of the times. Then only you can estimate what shall be the probable answer. And that's what is Monte Carlo method. So from where did this Monte Carlo method appear? So let us get to our presentation, and we were on, suppose, this slide. Okay, this one. So from current slide, let us begin the presentation. So Monte Carlo method moreover turned, or we can say got famous, when it solved the answer to the famous constant pi. Okay. Now, how to solve the constant pi using a simple method of a dart. Suppose this is a dart game. So this square is a dart chart, and you are having darts in your hand, many thousands of darts, and then there is a circle on the square. Okay. Now I can solve the equation of pi. I can give you the value of pi exactly by playing with you this game of dart. I will just ask you to throw your dart onto this square. So many darts which are falling inside the circle to the ratio of the total darts of complete played onto this sheet. That ratio into 4 will be pi. Now, how that formula appeared? It's very simple. If I take capital R as the radius of this circle, then the area of circle will be pi r square. If this radius is from the center of this, we can say square, then the complete length of the square will be capital twice r, twice of capital R. So it will be twice r, twice r. So area of square will be 4r square, and hence total number of darts on the square sheet will be suppose A, and total number of darts inside the circle will be suppose B. So if I take the darts inside the area of circle divided by darts on the square sheet, it will be pi r square upon 4r, and that ratio, if I know, then I can know the value of pi by 4. So if I take 4 to this side, I will be getting pi as 4 times V by A. That is total number of darts on the circle area upon total number of darts thrown onto the sheet. Okay. So if you don't believe me, I will show you this simulation in the Google Sheet as well. And also I have prepared a small program in Python. Many of you are well acquainted with Python. So let us go to the Python Colab, and where I have just made a very simple program to simulate this Monte Carlo simulation for pi estimation. So the program is importing some random number. We are going to have some random number generated because we want the random points of dart. Okay. The points to be generated, suppose 10,000, okay, or maybe 1 lakh. Okay, here are 1 lakh. Then inside we have labeled this variable as 0. Then we have started to run the program from 1 to 1 lakh of the times. Okay, so I is from 1 to 1 lakh. Then random x and random y coordinates are generated. Then we are taking the values of their, we can say, areas, x into x, x square plus y square, which should be less than 1. We have taken the circle to be of the size of 1. So those who are inside the circle will get appended with 1. And in this way, if I take the value of pi, so it will be 4 times number of inside points and total number of points. So total number of points are, of course, 1 lakh. Inside will be updated by this small call. And if I run this simulation, so estimated value of pi came out to be 3.1402. So over and over you run it. Each time you are generating random numbers, you are getting 3.14, nearly the answer. You can also have the simulation creating graphics over here using some graphic tools of Python. We are not going to go into details. I will put this into the assignments for you to make a graphical version of this pi estimation. So coming back to our Google Sheet. We also have the Google Sheet for this pi estimation simply, in which I have shown this example again. So suppose this is the dart sheet, this is the complete square in which this is the circle. Okay. And now these are my coordinates. I have generated random numbers on x and y axis, and then I have plotted it using the coordinate system. And then I have also plotted the value generated 4 times of this average. Okay. The coordinate value, and number of iterations will give me the pi values near to the correct answer. So if I iterate it only 5 times, I will get only 3.2 as an answer of pi. If I iterate it 10 times, I will get 3.1. If I iterate it 100 times, I will get 2.8. If I iterate it, suppose 500 or even more, I will start approaching the value of pi. Okay, so I have iterated it maybe 3000 times. Suppose if I reload the sheet again, the value may change a little bit. So somewhere in middle, I can also get the value of 3.14. Like after 10 iteration, I am getting 3.14, or maybe like this. So here I am getting 3.14 value, near to the 3.14 value to different estimations. So you need maybe some 10,000s or lakhs of estimation to get exactly near to the 3.14. Using Python, it was very easy. We iterated the program 1 lakh of the times. Using Google Sheet, there is a problem. It will take some time to reload the sheet, or it will take lots of Excel shells. Maybe you have to go up to 1 lakh, and then you will approach the value of 3.14. Okay. So that is what is the, we can say, the problem of pi is solved using this random value theory, or we can say Monte Carlo simulation. So now coming to the topic of Monte Carlo sampling using Markov chain. Now, till now, we have seen that Monte Carlo samples are generated randomly at each point, and then we are using them. Now, is it possible that if first iteration is generated randomly, and then second iteration will incorporate some condition to the previous step, and again some random generation? So that is called the Monte Carlo sampling using Markov chain. Instead of generating completely independent random variables for all the iterations, if we generate a sequence of samples which are having related with the previous step. Okay, so next step is generated with the help of the some of the status of the previous version, and then some random variation there. So that is called Monte Carlo sampling using Markov chain method, MCMC. Okay, that is called as. And the biggest example of this MCMC is my favorite, which is called as the drunkard's example. So how a drunk person going to reach the home is the simple example of random walk. This is the famous term in the statistical physics, or we can say the mathematical modeling. People must be knowing the random walk concept, that you decide one random variable. Then the next step of the random variable will be decided by the previous value plus some random condition added. The condition may be of your choice. Okay, like the man has taken one step. If the left foot has raised first, then the man is going to get 2 steps back. If the right foot has raised, then the man is going to get 1 step ahead. So you can have any kind of random condition. And this is an interesting game to see whether the man will reach to his destination or not. So let us get back to our sheet, and I have also simulated this random walk using the Excel. It's a simple example. I have taken the starting point of the man as 0. Here is his home, and here is a well. So let us see the the drunken man reaches the home or he falls into the well. So what a condition I have done is, I am generating a random number each time, and I am testing that previously generated random number is less than 0.5. Then I will take this number as -1. If it is more than 0.5, then I will take this number as +1 in plus, and this is added into the previous number. So each next step will be addition of the random number generated on the previous condition. Okay. So simple steps. I am calculating multiple steps. So random number, I am starting from 0. Then first random number generated. If this random number generated is less than 0.5, the next number will be next step will be -1. If this random number generated is greater than 0.5, the next step will be addition to this step and the -1 formula. So this will be -1 plus 1, minus of minus will be plus, so it will be 0. And so wise the steps will be calculated. So if I run this, suppose I have decided some, how many steps, maybe 500 steps, I don't know, or 1000 steps. To get a good sample, we need to have a large number of steps. So suppose 500 step I have decided. So if I reload the sheet, the random numbers are generated again. And let us see the man reaches home or falls back. Okay, the man has reached the home. So it's a very interesting game of generating a random walk problem, that so many times you are reloading the sheet, so many times, oh, this time the man has fallen into the well. So each time the result will be unpredictable, even though you are having a pre-decided walk structure, that if it is the random number generated is less than 0.5, then this step will be -1. More than 0.5, this step will be +1 added to the previous step. Whatever the condition you are having, each time there is a fluctuation and random output we are getting out of the two. Okay, so many times you want to run and you want to play the games. So this is the actual, we can say, the logic behind many of the electronically generated games, the app-based game or computer-based games. Okay. So this is the random walk problem. Now, using this random walk problem, you can also generate some random images. Okay. Someone may ask, what is the use of this random walk problem? So random walk problems are used to generate random images. Now, I will tell you this more further. Suppose let's go back to our slide which was going on. So this slide was going on, and let us keep this drunken man away. and come down to the actual applications of Monte Carlo or the randomness in the equations or the multiple iteration solving concept of statistical mechanics. So this is used in particle physics mostly, because in particle physics, if you suppose you have a reactor in which the particles are going to get created, so where the particles are going to get scattered, you don't know. So that is a completely random process. So particle physics mostly involved the randomness. Then in quantum mechanics, to know the probability of existence of particle in some of the portion of the quantum world, this is mainly used. Then in statistical physics also, then in the nuclear reactor, as I told you, then in material science to detect the presence of element, in astrology. So there are many fields where this random things are random, we can say randomness of equation or iteration is tested. So now I will show you this example of uh, particle accelerator, we can say particle physics. If I have a particle scatterer, so these are the scattered points produced. So if I now I will show you one beautiful example for the research oriented people. Like I have selected random number between 1 to 100 for x. I have selected random number between 1 to 100 for y, and I have plotted it on xy coordinate. Simple scatters plot. Now if I select this random number not between 1 to 100, but between 1 to 10 only. Why also if I select 1 to 10, but I run it for suppose many of the times like 1000, whatever is the sheet size, let us say, I am running random number generation. I'm generating 1000 scattered point inside a reactor. And now I am seeing the pattern. So can you see the pattern? All the 10 probable points, because the particles were only 10. So probability of getting their distribution is exactly same, 10 on 10. That is 10% chance for each particle to appear. Okay. So this happens when your data values are small, then the chances of getting fair enough distribution are more. If I increase the number of points from 10 to 100, suppose for X and Y, both I have increased from 10 to 100. Now random positions are 100, which are to be distributed 1000 times. Now this time I may not get a perfect distribution over 100 points. Okay, so 100 points on a 1000 space. Each may be getting a 10% chance, but now this time it is random distribution. So to get 100 points distributed correctly, I need to have more large data set. So this 1000 point on Excel will not work. I may have to go to some 1 lakh of iterations, and then I will get that straight line graph in which each point on the 100 point scale will get fairly distributed. So that's how the random number generation, simple random number generation in Excel can give the simulation of a particle accelerator. So coming back to our PPT. So now we have almost reached at the end of the session. So here this randomness or such kind of things are used. So in physics, randomness at microscopic level becomes predictable at microscopic level. Okay? So that is how the law of large numbers means. So for biggest example, I will quote the example from my model, which I have studied during my PhD thesis, is Ising model. Okay, Ising model tells you about the statistical mechanical formation of magnetization of a substance. Okay, magnetization is a property at a very ground level. The magnetic spin up or spin down, it's an atomic, we can say, property. So it is the microscopic randomness. The particle or the atom may be spin up or spin down. So it's random in the microscopic level. But when we take a complete material having crores of atoms, then their spin up and spin down distribution will orient the complete material into one of the magnetization categories, like non-magnetized or magnetized. In magnetized, it can be diamagnetic, paramagnetic, or ferromagnetic, ferrimagnetic, and many more. So this randomness at microscopic level, if we take iterated for so many of the times, because when we are talking about atom and when we are talking about crystal, we have iterated the same atom again and again and again and again crores of the time to form a crystal. So that is how the law of large number works. And the randomness at microscopic level gives you the complete magnetization model at the microscopic level. So that is the use of Monte Carlo simulation techniques. And now let us connect it to the mythology. Okay, I like giving examples of mythology. So in the Hindu mythology, we have very strong basis of all these things studied at a very huge level. So one of the philosophy Lord Krishna gave during Mahabharata in Gita was Karmanne Vadikaraste Ma Phaleshu Kadachanam Ma Karma Phala Heturgunama Ma Sangostava Karmani. So, the meaning is very simple that you have all the right to perform your actions, but not to control the results. Do not get attached to the outcomes. Now, how we can connect this to the Monte Carlo or the randomness, which we are talking about since last maybe 40 minutes. So, perform many actions. That is, the actions you are performing are random. Whatever the random situations are coming in front of you day in, day out, you are performing your actions random. Each individual results are unpredictable. Okay, I may perform in the same situation differently, you may perform in the same situation differently. Okay, so my one-time performance or your one-time performance is not going to give the output. The output is going to be produced at the overall pattern which is emerged after so many of the deeds we both do in our lifespan. So that's what Lord Krishna wanted to say, that do not worry about the ultimate statistical evaluation of yourself, that how you are going to get evolved as a person, because that will be the outcome of your uh, entire lifetime actions that you are carrying out randomly. And that is going to have a predictable, may not be predictable, but that is going to have emerged with some statistical pattern of your behavior, whether it will be towards good or kind behavior or whether it will be towards ill-fated behavior. So that is how we can say the randomness is connected to the Mahabharata or the Gita version. So we have discussed from the game of, we can say, dice of Mahabharata to the modern supercomputers, to the randomness, which can help humanity to the deepest, to evolve or to uncover the deepest secret, like the evolution of tossing a coin process or a dice game process, or maybe to find out the mysterious value of pi. So whatever the points possible during this span, I tried discussing with you. So here I am wishing you thank you in the random manner. So thank you so much, everyone, for a kind listening. So here I stop the presentation. And coming back to the screen. So if you have any questions, you can ask. I have also one small model prepared for icing explanation. If I can share that sheet, I should get that sheet first. So I need to share the screen. Just to
Okay,
show
now it is open. Now the floor is open for question and answer till the Bhakti finds the sheets. You think what you want to ask, and please feel free to ask questions. Either you
Excuse me,
raise your
madam.
hands, yeah.
yes.
Hello, madam. That you have shown that random walk of a drunkard man, whether you have generated that values, or how did you write that 500 points you have mentioned? How did you have calculated, or it is generated value, madam?
I will show you in the Excel sheet. It's a simple formula in the Excel sheet, random walk. Okay. This is random walk. So this is just a simple condition I have applied. I have generated a random number. Okay. That random number is between 0 to 1 actually. Whenever you are using RAND function in Excel, it is going to generate a random number between 0 to 1. Like here it is generated 0.588. Okay. Now I compare this number with 0.5. So if this random number generated is less than 0.5, I change the position. So to suppose -1. And if this random number generated is less than 0.5, I change the position to +1. And the next position I am taking as the addition of these two previous positions. So each time I am generating a random number, but the step I am taking is on the decision of this previously generated random number. So these are my steps, which are addition of the previous steps. And these are the generation of the random number. So it's a simple program. You can also design your own way of predicting. Okay, I have decided that I will add the 2 steps. You can decide that you can add 3 steps. You can decide that instead of comparing to 0.5, you may compare to 0.1 and decide further action. So this is a simple Excel formula sheet calculation. and you run it over and over again, you will get different results because each time you are generating random numbers. And then you are calculating the steps depending upon the random number. And then you are reaching the endpoints. This graphic I have just added to show you the nature of the random walk, where the walk is actually going. Okay, because that looks a little bit interesting to understand. And now this was the
Madam, we
icing
have to
model.
use Python.
Yes,
Madam,
you can use,
excuse me.
yes. You can use Python, sir.
We have to use Python only, or we can use any software to generate this.
Python is also very easily codable for such kind of random iterations, such kind of Monte Carlo simulations, because you can iterate the programs
Ah.
as many as time possible and it is very faster. Okay. One of the easiest way is Excel sheet. But Excel has a drawback that beyond maybe 10,000 Excel rows, the sheet becomes slower. Okay, you cannot load it for 1 lakh points again and again. So Python will be the easiest way to do all that thing. Excel is for the beginners to understand what exactly is happening at each stage. So this is the icing model I was talking about, that spin up and spin down are represented. Spin down is -1, spin up is +1. This is the temperature incorporation and this is the magnetization value. So suppose if I change any of the spin to -1, random, sorry, not this, spin value. Suppose this second spin I change to -1 and I press enter. See, the magnetization changes. So small change at a small value may have a huge change in the magnetization. So that is what is the small randomness in the microscopic level brings statistical results, steady results at the microscopic level. So this is simulation for, we can say, the Monte Carlo Ising model. So coming back to the window, okay, I will stop sharing over here. Yeah. So if you have any more questions.
Bhakti, I have a question for you.
Yes, sure.
Ma'am is doing.
We are talking about the statistical mechanics.
Kamal Singh, ma'am. Ma'am, good evening.
Good evening. You are talking about the statistical mechanics from hot to cold. Okay.
Yes.
So, are you taking distinguishable or indistinguishable?
I think they should be distinguishable, so that if you want to have the MC kind of a structure, if you want to have the previous step incorporation, then because I have not gone much more into details of that statistical mechanics hot to cold structure, but
Okay.
yeah, because I have not touched that portion in these 7 days to get explained, because this much was material much more collected, so I thought the time
Because
may go
when we
beyond.
talk about the Bose condensation, it will be indistinguishable, no?
Indistinguishable. Okay.
Thank you.
Please take ma'am on panel.
Thank you.
Yes, if she turns on the camera, she is visible on the panel.
And Rajesh sir has joined. Dr. Rajesh Nimat. Is he there? Okay, let me check. Any other question?
Good evening, ma'am. Bhakti,
Yes.
ma'am.
Yes.
Thank you for your wonderful explanation. This is Shivani from Solapur University. I'm a student of physics doing my PhD. Actually, I wanted your point of view. Where can Monte Carlo method be applied in material science? Because I specialized in material science and curious to know about it. So could
In
you please
material
help
science,
me?
Monte Carlo or such kind of mathematical modeling techniques are generally used for modeling phenomena which you cannot work on the labs. Like we have used for mainly magnetic behaviors, the transitions from one magnetization to other. So that can be easily studied using mathematical modeling concept. So such simple programs, during my PhD, I have used the simple C language program, and then we have plotted the transition plots, and then we have used that to establish some sort of we can say exponent law, universality, etc. So such simulations are mostly useful when you cannot have the large number of data set produced in the labs, where you cannot have so many of the transitions generated in the lab. So at that time you can run the program having some lakhs of simulations, and then you can have a simple mathematical plot generated, and then you can interpret that one. Okay, you can always do the practical work, but with the small amount of data. Okay, because each data, whenever you are performing a practical work, it will require some time. So for some small thing to get a result, you may require 1 hour. So to run 1,000, you may require 1,000 hours. Okay, that is so many of the days. So for that thing where you want to, we can say, extend your data set beyond the practical doable values, then you can use such kind of simulations. And they are
The
basically
best
designed for large
example,
data sets.
sorry, the best example is AC conductivity, Monte Carlo. In material science, if you measure AC conductivity from hertz to megahertz by taking the various temperature and pressure, you can apply them.
Okay, thank you so much, ma'am. Actually, I work on supercapacitor, a sphere from energy physics. So I was curious to know about it. Okay, ma'am. Thank you so much.
Participants, any other question? Even Professor Kamal Singh is with us. So
I have a query that if we are given assignments to do, then how to bring that Monte Carlo simulations from the collabs into the Excel sheet, or what is it? I couldn't understand
You just
what
design the
is.
formula in the Colab. In the Google Colab, you are having a Python program. So you have to design the formula for that Python programming, and then you have to loops for iteration. In Excel sheet, we have to have the formula in one sheet and then we drag it. So it's a simple thing. We are dragging means we are iterating. In Colab, we are iterating in the form of a loop. Maybe if loop, for loop. Okay. And then the formula is inside the loop. So you are generating the value. So that's the way how you interchange the two.
How you plotted that graph of pi value in the Excel sheet with Monte Carlo simulations in
Uh,
collabs?
in collabs, we need to have the plotting tools required. Okay, so that's why I have not used that one because that would have increased the length of the program and made it complicated. Otherwise, you can always have the plotting tools in the Python programming. There are some tools in which you can have the points to be plotted and then you can generate the simple values. If the time permits, later on, I may share that thing in the group.
That means in collabs I can download an Excel sheet from the collab and paste it in the Excel file.
Oh, you make a program, you run it. In the program itself, you can have a graphic tools incorporated to show if you want to have some graphic representation of that pie or the DAT game. Or otherwise, you can just generate the data and you have the formula and you get the value directly using the formula. There is no connection between that Excel and the Google Colab. They are two separate tools actually.
Thank you so much.
So I'm also answering the questions in the chat box. Can we do the comparative study of distribution of particles in materials at various temperature using Monte Carlo? Of course, you can do. You can use Google Colab also. You can use Excel also. If your data sets are very large, you use Google Colab and you provide the conditions of temperature and etc. These are the variants, which are bringing more, we can say, randomness to your answers. So if you do it properly with different values of temperature, you can also have the study of distribution of particles. Okay.
Okay, ma'am. Thank you.
Okay. Thank you so much. Dr. Bole, KG Bole sir has also joined.
yeah, and Mahesh Shetty sir, President RC08, and Dr. Nimat sir, Rajesh Nimat, he is also joining, and Rekha madam is also joining in 2-3 minutes, so we can start earlier. But now I request our chairperson, Dr. Nilesh Ugemuge, to kindly share his closing remarks for this session. Over to you, sir.
Yeah. Ma'am, very good evening to first my teacher, Dr. Kamal Singh, ma'am. Ma'am, very happy to see
Thank
you
you.
after long time. And really much happier to see you and your words over here. Thank you, ma'am. I hope you are fine and you are good
Yeah.
with health and all
Yes. Yes.
So, and really, Bhakti ma'am has given wonderful session on Monte Carlo simulation. Still, I remember the days when I was there in IIT Bombay. I went there to learn the Monte Carlo simulations. There were one Dr. Kunwar. He is very good friend of mine in IIT Bombay. Still, he is professor there. So, like he went to US to learn the Monte Carlo simulation, and he's a physicist turned to biologist. And he has given one of the example in those days ki, like when we want to remove the tail of any of the mice, then it's much difficult to have many experimentation as a biologist. So in that case, if we use Monte Carlo simulations, then we may come across to the solution at what time that tail can be removed. So in that way, there are many examples where we can apply the Monte Carlo simulations. And really, I am not I am not much. I have not done much more in theoretical physics or in theory. So really, I'm happy to listen from ma'am many things about Monte Carlo simulations. So thank you, ma'am, for your wonderful sessions and many insights and how to apply Monte Carlo simulations for the learners like us. So it's a really good opportunity to learn from you, and definitely I will again get back to the theory or the theoretical, and then I may try something to combine with the practical. So where we can apply like a theory for the improvement of our, and again to save the time also. So one thing, as we know, when we are shifting towards machine learning, when we are shifting towards artificial intelligence, then we are thinking how do we save the time of dry wet lab, because in wet lab we have to do many experimentation to get certain solutions. So in that case, this kind of approach of simulations must be useful for all the researchers, and in that way we can take much benefit from this kind of approaches. So thank you so much, ma'am, for reminding me the days when I learned Monte Carlo simulations. And I'm very much happy to have Kamal Singh, ma'am, and again, like some words related to statistical mechanics. Still, I remember the lecture where, when I learned statistical mechanics from ma'am. So it was like the lecture for entire day. And I'm every time I'm giving example of ma'am. Ma'am used to come at 8 a.m. to the department, and our lecture ends at 6 p.m. So that enthusiasm still I remember, and again with that samosa and all, like, so thank you so much, ma'am. Still I remember,
You,
and I'm
you must be cursing me.
Ma'am.
No, you
Keep
must be
with
cursing.
your student.
no, I'm not cursing. Basically, I feel that kind of energy, like we must have. Like we
Yes, ma'am.
cannot. जब मैम बोलते थे कि मैं just I came from Delhi, and then like मैम used to deliver. मतलब मॉर्निंग की फ्लाइट से दिल्ली से आने के बाद में, और 8 बजे से लेके 6 बजे तक, मतलब दैट वाज अमेजिंग डेज. हम लोग कभी भूल नहीं पाएंगे. तो दैट वाज आवर लाइक गोल्डन ईरा ऑफ डिपार्टमेंट, वी कैन से रादर.
Correct. So
Thank
as
you
we
so
conclude
much.
the technical sessions of this workshop, it is my pleasant duty to propose a vote of thanks on behalf of the Association of All Computer Science Teachers and IPT RC08. I would like to express my sincere gratitude to our resource person for today, Dr. Bhakti Patankar. She has generously shared her knowledge and expertise throughout this workshop, and it was her presentation is always like never miss kind of thing. So I love her presentation, how she makes it. And my heartfelt thanks also goes to the chairperson of the session, Dr. Ogemuge, and all the dignitaries, Professor Kamal Singh Madam and Professor Rekha Gorpade Madam has joined. So I would also like to extend my thanks to her, to both of them. And finally, with sincere thanks to all the participants and research scholars, students, for their enthusiastic participation and active engagement throughout the workshop. So with this, we conclude the technical session of the workshop. And now we will proceed to the valedictory session for our this particular event. And for that, because Dr. Bhakti Patankar Rajvaidya is the host, so now I request her to kindly take over the proceedings. Thank you. Over to you, Bhakti.
Thank you, ma'am. So, first of all, welcome to the concluding, we can say, ceremony of our 5 days national workshop on advanced computational tools for physical sciences. I welcome Honorable Dr. Kamal Singh, ma'am, and I also welcome Dr. S.B. Kishore, sir. I also welcome Rekha Ghorpade, ma'am, from IIPT. Also, Dr. K. G. Bhole, sir. Thanks, Bhole, sir, for being here today. And all the other dignitary person from IIPT, AACST, I extend my warm welcome to you all, to all the we can say resource persons for the last 5 days, to all the chairpersons. I extend my welcome. Those who have joined today, those who are kind enough to join. Some of the chairpersons voluntarily joined for more than maybe 1 day of theirs for the excitement of the topics. So, as being the convener of the workshop, this is my proud privilege to read the report of this workshop. The workshop has been conceived in the brains of our mentor, Dr. Abha Khandelwal. Then she proposed to me that whether you will be taking such things. So I read the topic and I like the topic as always, because the topics were challenging. And I asked her that make me one of the resource persons so that I can learn the topic. Okay, because unless and until you are forced to do so, you don't do that. So she is the one who has been forcing me for last 2, 3 sessions to learn new things and make some presentations and try to explain that to others. So all the topics were very interesting. Then we have got fortunate enough to get 5 different resource persons, 5 different experts in their domain who explain the topics. Then we have 5 chairpersons to share the session, who has also summarized the session as at the end. Then we circulated this workshop flyer everywhere, and we got so much response from 9 different states of India, maybe more than 15 plus cities, and I can say 56 participants have joined, out of which daily the attendance percentage is more than, I can say, 90%. So thank you, one and all, who are directly, indirectly involved. Also, the efforts from the IIPT, the support from Mahesh Shetty sir is again unparalleled. The support from Jayashri madam is again, I am very much thankful to the persons for their kind encouragement and support. And then, to conclude the ceremony, uh, 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 I may ask, before we proceed for the speeches from our guest of honor and the chief guest, we may have some feedbacks first, ma'am. Feedback from maybe one of the resource person, feedback from one of the participants, if we have the time. Abha, ma'am,
Yeah,
can you?
you let me speak first,
Okay,
and
okay.
then it
So,
will be followed by resource persons, and then
okay,
feedbacks from our participants, and then we will start with our
okay,
chief guest, Mahesh Shetty, matlab, like that. I'll tell you. Okay,
okay, okay.
let's go.
So,
And first of
let
all,
me.
you please bring on panel Dr. S.B. Kishore, President ACST, Mahesh
Yes,
Shetty sir,
he is there. He is there.
there,
I have
Shetty
taken the grid view.
and
So
Rajesh
those,
sir also.
yes, yes. So, sir, please turn on your camera so that we can
Cameras
see.
are not on, so perhaps, and Dr. Bole, all
Yes,
of them.
Bhole sir has also joined. Shetty
Uh,
sir has also. Good evening, Shetty sir. Nice
uh,
to see you.
so,
Good
So
evening.
yes, all have turned on the camera. If you
okay.
change the view to grid, you can see all the faces, smiling faces in the workshop.
Yes, yes,
So
yes.
over to you, Abha ma'am. Please offer your concluding remark to the seminar workshop.
Thank you, Bhakti. Namaste. Chief guest, Honorable former VC, SGB Amravati University, Professor Kamal Singh, Madam. Guest of honor, most respected General Secretary, Dr. Rekha Ghorpade, Madam. Respected President IPT RC08 Mahesh Shetty sir. Respected IPT RC08 Secretary Dr. Rajesh Minath sir. Respected President AACST Dr. S.B. Kishore sir, and a special thanks to him, even he has fever, but on my request, he is with us for half an hour. So thank you very much, sir. And esteemed chairpersons, our eminent resource persons, convener, fellow teachers, research scholars, and dear participants. As we gather for the valedictory session of the National Workshop on Advanced Computational Tools for Physical Sciences, I feel a deep sense of satisfaction and happiness. For the past few days, we have shared a wonderful academic journey, a journey of learning, discussion, curiosity, and exploration. Workshops like this are very special because they bring together with a common passion, people with a common passion and the passion to learn, to grow. together. There is a simple proverb that often I like to remember: learning is a treasure that will follow its owner everywhere. Knowledge and insights that you have gained during this workshop will stay with you and will continue to guide your academic and research journey. Today, science is evolving in a fascinating ways. Boundaries between disciplines are slowly disappearing. Physics, mathematics, computer science, engineering, all of them are now interconnected through a powerful common language, the language of computation. Let me share a small personal experience with you. When I began my academic career, I was first a physicist. Physics taught me how to think logically and analytically. It trained my minds to observe nature carefully and ask meaningful questions. And my academic mother is with us today, Professor Kamal Singh. But around 1990, something very interesting was happening in the academic world. Computer science was emerging as a powerful and exciting discipline, and there was a sense of curiosity everywhere. Like many others, I too felt drawn towards this new, charming field, and driven by that excitement and possibilities it offered, I decided to move into computer science. At that time, the subject was still in its early stage in many universities, including Nagpur University. I was fortunate to work with a dedicated group of colleagues, and together we became part of early team that helped shape the computer science program during its formative years at RTM Nagpur University. Looking back today, I feel grateful that I had the opportunity to contribute to the growth of that discipline. Later, while designing BSc Computer Science curriculum, I strongly believe that students should not only learn programming language, but also learn powerful open computing environment. At that time, when many institutes were hesitant to adopt Unix and Linux, we introduced them one after another, first Unix and then Linux, into the syllabus. The idea was simple: students must have the freedom to explore, experiment, and understand system deeply. Today, when I see students confidently using Python, computational tools, and simulations, I feel happy that those academic decisions have helped many learners move forward. The idea of organizing this very workshop also emerged from a similar thought. Modern science is becoming increasingly computational. Whether we talk about artificial intelligence, photonics, material science, or statistical physics, computational methods are now essential tool for discovery. That is why we tried to design this workshop around some important emerging domain, including physics-informed artificial intelligence, computational luminescence, optical trapping and photonics, density functional theory, Monte Carlo methods in physics. And I'm extremely grateful to all my resource persons who generously shared their knowledge and expertise with great enthusiasm. They literally answered each and every questions even after their sessions were over, and for next few days the participants were asking their queries in the group. So each and every query was answered. I would like to appreciate our convener, Dr. Bhakti Patankar Rajvaidya, whose dedication and hard work ensured the smooth and successful organization of this workshop. I firmly believe that the knowledge grows when it is shared. And I appreciate my resource person team who too believe the same. Organizations like AACST and IPT provide exactly such platforms where teachers, students, and researchers can come together, exchange ideas, and grow collectively. Before I conclude, I would like to say something especially to our young participants and research scholars. Please do not limit yourself to only one discipline. The future belongs to those who can connect knowledge across fields. A physicist who understands computing, a computer scientist who understands mathematics, a researcher who understands real world problems, and so on. Such combinations lead to powerful innovation. I sincerely hope that this workshop has sparked curiosity in your minds and encouraged you to explore the fascinating world of computational science. Let me conclude with a thought that beautifully captures the true spirit of education. The mind is not a vessel to be filled, but a fire to be ignited. If this workshop has ignited even a small spark of curiosity in your minds, then our efforts have truly been worthwhile. Once again, I thank all the chief guest, the guest of honor, presidents, President IPT RC08, President ACST, Secretary IPT RC08, organizers, volunteers, and participants for making this workshop meaningful and successful. Let us continue to learn, to share, and to inspire. Thank you very much. Over to the host, Dr. Bhakti Vaidya.
Thank you, ma'am. Again, to offer the, we can say, concluding remark to this valedictory ceremony, I would like to request Mahesh Shetty sir to please say a few words.
Thank you, madam. Okay, thank you, Ava madam and Bhakti madam and all the other dignitaries over here. On behalf of IIPT RC08, Secretary Rajesh Nimat sir will be talking. I will just use few words here because last 5 days, though I was not able to attend regularly, one representative from every sub-regional council was attending from Maharashtra and either proposing vote of thanks or welcoming. I make one request to AACST that all these lectures which are recorded, okay, if they are made available to in general, because IIPT's aim is the teacher development, and that's one of the very prominent and prime aim. Under the national education policy, the field project and various kinds of activities teachers have to conduct for students. So these tools, if they are available as online resources, it will be really very useful that the teachers can learn and teachers can give this to students, and different kind of training and field projects can be made available. I request Rajesh Nimat sir to represent IIPT RC08 and speak.
Thank you, sir. I'm audible?
Yes, sir.
Yeah. Respected Khandelwal madam, coordinator of this workshop, Bhakti Vaidya madam, IIPT Central General Secretary, Gorpani madam, IIPT RC08 President, Professor Shetty sir, and all the dear participants and dignitaries that are present for this valedictory function. Actually, let me thank first of all Khandelwal madam and Mahesh Shetty sir and Bhakti ma'am for having such a great national workshop on advanced computational tools for physical sciences, and for having a MOU. We have formally signed a MOU between the ACST and our RC08 IIPT. And as a first activity, we have conducted this national workshop on computational tools for physical sciences. Due to my some university assignments, I could not attend any of the session. And that's why I was suggested I will attend on 13th of the March. But actually, this is the valedictory function. So the theme of the workshop, it is the computational tools for physical sciences, and it will definitely help to our research students because it was actually conducted for the postgraduate students and research scholars. And many of I think students, they are using data, and they are using machine learning. And actually, the DFT study is the hot area nowadays in physics because all of the research scholars, they are doing the density functional theory, whatever they have obtained the data, and they try to analyze that what are the band structure, what is the band structure of their compound, and all these things. and very good or very high impact factor papers they have been published by students, and definitely this workshop will be helpful for those who have attended this. Actually, I want to study this DFT theory or this computational science behind that, but unfortunately I could not attend. So as pointed by our president, Mr. Professor Shetty sir, I also request to share the videos. If it is possible for you, you can share with us, and we can share with our IPT community, so that they will be benefited. So with this, I also request Khandelwal madam that we can have such a uh, workshops in coming future also, because we have signed a MOU, and even in MOU I mentioned that at least one activity we can frequently arrange such kind of workshop. Actually, the 56 number is very good number. Actually, initially I thought whether students will join or not, but actually when I see the 56 participants they are registered, so it is very good number, and definitely resource persons were also very good. They have definitely shared their knowledge, and they have deliberately done the discussion on this platform. So we can have more number of workshop in future also. We can organize. We will involve our remaining also all IPT members, because now we have involved only three: Mahesh Shetty sir, me, and I think Bhagwani madam. But in future also we will have such a kind of workshop, and definitely we'll arrange this such kind of workshops. Regarding this financial matter, I definitely it will be settled by Monday. Actually, I have ma'am dropped yesterday the check of 6,800 rupees, but it could not materialize. They have raised a query regarding the signature of this treasurer. So today I could not attend this bank regarding that, but on Monday I will definitely go to the bank, and I will resolve that issue. So I thank the organizers for having a very good this workshop on computational tools for physical science, and I also thank all the participants, those who have participated. Also, especially thank to the resource persons, because without resource persons it is not possible to have such kind of workshop to conduct. So I also thank this our IIPT office bearers, Mahesh Shetty sir, Bhagwani madam, and all other. So that with this, I also request to have, again, I am repeating that we will have such a workshop in future also. And with this concluding remarks, I thank you, the organizers, for giving me this opportunity. I hand over this, Bhakti ma'am.
Thank you. Thank you so much, sir. Definitely, we have shared the video lectures for all the days to the participants. I have created one drive link, and the link is being shared to all the participants. I will also share the same with you, so that you can also go through the lectures later on. Even if you could not attend the lecture, you can always take the essence of them later on. So thank you so much for your kind words. Now, I would like to request some of the participants who have visited these 5 days, because whatever the things we as an organizer are saying will not be felt true if we hear the same thing from the participants. So I request the participants to please unmute yourself if you want, and please uh, give us the honest feedback for the workshop. Whatever may be the way you thought of these 5 days, you please express, so that we can also have the improvements in the future, and whatever. So please, like Sarang, who has messaged me about the feedback, but I ask you to please, if you can unmute and just speak up. Yes, Mr. Sarang, are you there?
Yes, ma'am. Actually, we are here together in the college. So
Okay,
he will speak. We are attending from the
yeah,
same.
yeah.
Especially, madam, I found it is very interesting that you are sharing all PPTs as learning resources. So that is very useful for revising all the sessions. So it was great initiative from your side. Thank you.
Thank you so much, sir. If anyone else, please, would like to express the view, please unmute yourself, and we can directly hear. Also, please Yes.
Namaste, madam.
Namaste, sir.
I am Dr. Vishwas from Ruputunga University. I am working as a professor of physics in that university. Actually, I was doing research on experimental physics, and it is very amazing that we know how to make simulations and how to do theoretical research also. So actually, I am just started doing research in theoretical sciences. So I am planning to do density functional theory experiments on thin film transistors. We have done some research on thin film transistors, MOS capacitors, etc. We have to use this for theoretical for comparison. We have to make simulations also, and how to improve the efficiency of solar cells. We are doing work on perovskite solar cells. So actually, I want to know any collaboration is possible with IAPT, madam, because those who are interested in research, if they help, if they are know more about the theoretical research, if they help us, we can do collaborative research also. I want to know, and I expect I am very grateful to Abha Kandarwal madam, because she is very energetic and she is very enthusiastic, and she is very much interested to make some service to the teachers, and to improve the theoretical knowledge of the teachers. So I thank Abha Kandarwala madam and Bhakti Patankar madam also for their efforts to conduct this national workshop successfully, and their interest to encourage the teachers to learn theoretical science. Thank you very much, madam.
Thank you, sir.
Thank you so much, sir.
We have IAPT General Secretary Rekha Ghorpade madam. So in her speech, she can assure you that they can make efforts in collaborating for research purpose. IAPT can directly collaborate, or you can get it attached directly with them. So that
Okay,
can.
thank you very much, madam. Thank you, madam.
Thank
And
you.
I request you to hold this PPTs online for a few days, because we have to learn something about that lectures.
Yes, sir. Yes,
So
sir.
in one day we can't learn density
Yeah,
functional theory.
and
So for 1 month or sometime, you please keep that PPTs in that drive, madam. Thank
we
you.
will try to
Thank
put that in our website as well. Our
Yes,
website is www.ascst.org. I'll share
yes, madam.
in the group, and in IPT website also it will be there. So it will be permanently somewhere. So you need not
Okay.
worry.
Thank you so much, madam. Thank you.
Thank you so much. Now we can move ahead with the program if
Resource person, yeah.
yes. So anyone from the resource person? No, actually resource person.
Okay, so let's move ahead with, let us call our chief guest.
Yes. So let us begin with the guest of honors address, and then at the end we'll have the presidal address by chief guest. So I would like to request Rekha Ghorpade ma'am to please say a few words and guide us on this occasion. Also guide the doubt raised by one of the participant regarding collaborative work with IIPT. So I'm sure you are the right person to talk about. So over to you, ma'am.
Thank you, Dr. Bhakti. Respected Chief Guest Dr. Kamal Singh, Vice Chancellor, Sant Gadge Baba University, Dr. Abha Khandelwal, convener and the founder of AACST, Dr. S.B. Kishore, Secretary, Dr. Bhakti Patankar, Professor Mahesh Shetty, President, Maharashtra Regional Council, Dr. Rajesh Nimat, Secretary, RC08, and Dr. KG Bole, RC08B President, and all the dignitaries and wonderful participants here. I am first of all accept my apology because I could not join on the first day, even though Abha Khandelwal madam pursued it. We had a meeting, a Mumbai Regional Council meeting, and I was delayed to reach home, so couldn't join the meeting that day. But I was taking a summary every day, being a admin for Zoom account. I was getting the summary of the program and I was going through the summary. And it was really wonderful to know the coverage of the topics, right from the neural networks to the computational physics using computation in the density function, etc. First of all, let me thank Dr. Abha Khandelwal for making us a part of this very innovative national workshop. And nowadays, the computational tools have become a very, very important aspects of physical science learning. I also feel very proud here to join this function because as Abha Khandelwal has a special connection with IAPT because Indian Association of Physics Teachers was founded by a visionary teacher, Dr. D.P. Khandelwal in 1984, who is the uncle of Dr. Abha Khandelwal. And that blood is really showing us in the organizing functions here. And she is definitely doing a great work, not only as a AACST founder and secretary, but I think her contribution to physics is also wonderful. It is visible in our IAPT group also. And she is really dynamic and keeps trying for getting things done with the help of physics teachers and the computer science teachers. I think it is a wonderful collaboration which is going to help IAPT in a to a great extent. I also appreciate the efforts by Maharashtra Regional Council under the leadership of Professor Mahesh Shetty, Professor Rajesh Nimad, Bagavade Madam, and the other presidents, secretaries, and other EC members of sub-regional councils also. I think this Maharashtra has set an example of great collaboration of communicating with each other and reaching to the unreached, which is the actual motto of our IAPT. And being the 5 regional councils here, so we have Mumbai, Pune, Kolhapur, Marathwada, Vidarbha. We are covering every region, which is an example in front of the other state councils of IAPT, I think. And this particular workshop is going to give us a model for the others to emulate actually how the workshops can be conducted and what kind of having a very rich content also. Now, as Madam has suggested, actually, I was going to ask whether we can upload these sessions on our IPT website also, which is a dynamic website which has a reach of 10,000 plus members from across the country. I'm also happy to know that the participants are really wonderful. Some of them I know them for a long time also. And participation of 50 plus members, I think is a great participation and the entire organizing team deserves a great round of applause for that. Uh, so I also would like to appreciate and thank the wonderful content delivered by the resource persons. All of them were really eminent personalities from their fields, and they have really delivered a good content. And I shall go through the videos, of course, in detail, though I have gone through the short summaries here. Now, I'm really interested to know exactly what computational physics is. So I think I'm looking forward for a long association with AACST, and we both will do a lot of work for the betterment of physics and the computer science teaching community. With that, I thank each one of you. I compliment each one of you, and looking forward to hearing from you all. Thank you, madam.
Thank you so much, ma'am. That was very kind of you to say those words. And now I
Just
would like to, yes, yes, sure.
Sorry. One of the participant wanted to know whether there could be a collaboration from IAPT for the work. Yeah, yeah. We definitely do have. You can get back to us on our website actually. On our website, we if you can write, there are, as I told you, there are 10,000 plus members from across the country. You definitely will have people with whom you can interact from your field. And the people, the teachers and the researchers are ready to collaborate. So there will be a great exposure if a person, I think Dr. Vishwas, if I know that, yeah, I urge and I request the physics teachers as well as the computer science teachers to become a member so that you really get the benefits of interactions and collaborations in your respective fields. Thank you.
Yes, I'm sure, Dr. Vishwas, your query has been well handled, and you will act accordingly. So, without further ado, I would like to call upon the chief guest of today's function, Dr. Kamal Singh, ma'am. So, ma'am, please provide your valuable guidance over this occasion. We are really fortunate enough and thankful to you for joining with us today. So, over to you, ma'am, please. Ma'am, please unmute yourself.
Sorry. I'm extremely sorry.
No, yes, fine.
Good evening to all of you. Indeed, I'm very happy because I'm feeling that once again the life of the student has begun. That is the best life in everybody's life. And after really hearing Bhakti's lecture, because I joined little bit late, and I am feeling bad that why did I not attend for all 5 days. Abha has made me know, but I was busy in many activities. I still keep on doing things. So let me get back to all of you. First of all, let me congratulate the convener, that is Abha Khandelwal. You know what is the meaning of Abha? Abha actually comes when the sun rises. Before the sun rays come, its Abha a glow starts coming. And I'm going back to year 1990. Because that was the time when people were thinking that we're giving more importance to electronics. And there was a dearth of job in physics. So electronic was added, and simultaneously people started thinking of computer science. I had worked with computers in 1984 in University of Uppsala. I used to collect my data on the magnetic tape, and the output was very, very big. But now it is all Greek and Latin. So let me, indeed, it is a matter of proud for we all Indian in general and Nagpurians in particular, where we have people like a personality like Abha, who is head to toe, is nothing but the enthusiasm, nothing but the energy, nothing but a glow which is always ready to make light for others. And that is the knowledge of the light. And the title of the workshop I have liked because National Workshop on Advanced Computing for Physical Sciences. And whatever I have listened so far, we were talking about physics, it's very nice, but I'm very sure that we would have also talked, because I have not listened to all the lectures, so I'm not aware of the full fact, about the chemistry, about the statistical mechanics, and also about the mathematics, and also about the material science. Now, many subjects have come where this knowledge has become that we cannot go without this. So the tools have to be taken into consideration is like providing a mental right kind of food for the generations who are going to march ahead in the total environment of AI. Last 10 years back, when for the first time AI was introduced, we were thinking artificial intelligence, and many people were not trying to get into AI. And again, this lady came with a torch, Abha, and gave us the Python. 2 years back, she started with a workshop. And let me tell you, I was attending it at the age of 79 or 80. Now 82. So what I'm thinking that this advanced computational tools for physical sciences is going to open a big gate for all of you. And Abha herself has said that what journey she has made, because when she was doing physics, she was very good physics student in the Institute of Science. And one thing about her, people may not be knowing, as she addressed my academic mother, I was very impressed by the Khandelwal family. Rekha madam has already initiated why Khandelwals are important to us. And Abha is carrying the genetic code. Her sister also. But these two sisters used to come to do MPhil in the campus. They used to travel from Kamti, put the vehicle at the railway station, and then these two girls used to travel to and used to work up to 8 p.m., sometime 9 p.m. So, हिंदी में एक कहावत है, होनहार बिरवान के होत चीकने पात. Birwan means a plant. Chikne means very glittering, very shining, and very soft and smooth leaves. So the plant which is going to be a beautiful tree, it is very visible right from its growth. And so was these two sisters. So I'm very confident about, and not one workshop, but she is conducting series of workshops, and those workshops are not repeated. Various kinds of the subject. And one more point to be noted for all of us, Rekha madam has mentioned about the IAPT, and people have mentioned about the collaborative work between these two. That is already in process. Only it depends how all members of that IAPT or members of this group, they knit together, they understand together that they are going to lit a torch, and which is going to be very, very important from the new technology in computers, which is setting in. So that is very important for all of us. And when we talk about that, really, how the environment will be, how this academic environment will be. If you look at the new education policy, but on this side, which Abha has taken and her team has taken, people have not thought of it. They have introduced this curriculum right from the 5th standard in the school. But no teacher is no teacher is being trained in that manner as Abha has really started the work. This is a real kind of work which is most needed. And I keep on telling her whenever we both talk, beta, you start with the student, beta, you start with the teacher. And has already taken right step. She has contacted the schools, she is in touch with them. And if she would really make the teachers who are teaching fifth onwards to the high school, that will become wonderful, because no school, Abha, is really taking into consideration. This is a very, very beta important point. My own granddaughter, she is doing AI and talks about, but the game has become very easy, but it should not enter the way it has entered. So I would request all of you to not to forget this point, because it is very important. And the most important thing that she started with Linux and all that, which was very, very essential. That time people were not thinking of Linux. They were a little bit afraid to work with the Linux. But Abha had taken lead. And she recognized the future of the scientific research by taking such things in the hand, which is going to lead a fundamental path. I'm not very much highly impressed by AI, because I have some reservations for that. It is not I'm against or any such thing. You all may be knowing more than I know how it has been spreading the jaws. That should be not that with that speed. It should be, but it should not become the source of money. PhD thesis should not be really sold by them, where I'm really concerned with. So how you will take care of it, because I can expect a lot from Abha and her team, because whatever you young brain decide, you can achieve it. Whenever I hear your lectures, I get wonderstruck. Today's Bhakti's lecture was so fabulous, ins and out. And I think I'm forgetting the name of the boy who mentioned me that I was a very giant, very bad teacher, make them study day and night.
Okay, Mukesh sir.
Uge Muge sir. Nitin Uge Muge. Isn't it, Nitin?
I'm Nilesh.
Oh, sorry, Nilesh.
I'm no bad teacher. It's
Because I used to address them by first name. So
Yes, ma'am. Yes.
my favorite subject is statistical mechanics.
Statistical mechanics.
Yeah, still I like. So that was actually a difficult subject, and people never used to understand even the concept of the phase space. Nilesh will agree with me. So Abha, you have become a jewel in the crown in the field of computational tools and computational science. I want not many jewels should join you, so that it becomes a big garland which will not let any reflection go unmissed. Complete reflection of your jewels. You have to nourish them. We have to polish them. And it should be so glittering that we all should get drenched and take totally absorb that knowledge which you are doing. So I'm very much impressed by you, little girl, that now you may be whatever age, forget about. For me, that little Abha. So Abha will put her Abha into all your fellow people. And as your participants have requested you, I'm also requesting that whatever lectures are being done, it has to be made in the book bank sort of thing, and they should be either you can publish them or you can put price because you need money to manage your expenses. I can understand that point. I know that. I'm not asking there people are collecting money. Please do not misunderstand me. I'm saying, so those notes, those lecture notes have to be provided. Even I need it. I have attended Python. I have attended your quantum computing, all, but now it has erased from my mind. Maybe because I'm very old, I'm not using it. So this is what I would like to pen down here, that you people are doing a very, very great job, Rekha. And Abha, I'm very confident. She walks with not a random walk. Her walk is very straight walk. And that step she takes, those steps are the confident, and she think first, then ती विचार करते की मला काय करायचं आहे. Thought before the execution. Thought, planning, and execution. And the result is hers because she is having utter confidence in herself. Her doings are very poised. Her paths are straight. She does not have any selfish motive. So this lady is going to be like a Lady Kabir. Bless you, my child. Thank you. Thank you very much to all of you.
Thank you so much, ma'am. So there is one message from Dr. S.B. Kishore, sir. Let me read for you, sir. As he said, he is not well, so he could not speak. So excellent remark from Honorable Chief Guest, Kamal Singh ma'am. And we have lot many things to do. And they are assuring you, ma'am, that they are going to have many more such planned workshop for the betterment of teacher kind, we can say, student kind, and the mankind, of course. So thank you so much. We will keep in mind the single words, whatever you have blessed us with, and whatever you are expecting from the both the institutions. Both the institutions are being kind enough for me as a person, because I belong to both the families, to IIPT and to AACST both. So I have been working with both the families, and both the families are kind enough to shower their blessings on me. So I hope the same will continue. And to all the participants also. So thank you so much for joining this wonderful journey of 5 days. To all the dignitaries, thank you so much. The chief guest, Dr. Kamal Singh ma'am, also the guest of honor, Rekha Ghorpade ma'am from IIPT, and Mahesh Shetty sir, Rajesh Nimat sir, then Kishore sir, okay, and many more. I may miss the names. KG Bhole sir, who has have to leave early for some important work. Then Jayashree madam. So all the dignitaries from both the institutions, I am really, really thankful to you from the bottom of my heart for taking your valuable time and for helping out in this conduction of the workshop. Also, my thanks are due to our mentor, the guiding force behind all these workshops. As Kamal Singh ma'am quoted very clearly, the Abha of all these rising workshops. So, thank you so much, Dr. Abha Khandelwal ma'am, for always motivating and coming along such kind of inspirational ideas where you cannot say no to her because the idea is so strong. So, thank you so much, ma'am. And to all the participants, thank you so much for your the participation, enrollment. It's a kind of encouragement to the organizing associations that there are people who are ready to learn. There are people who are treating themselves as lifelong learning. So thank you so much for your enrollment and the whatever the learning experiment experience you have got. I'm sure that is helpful to you for your future endeavors, definitely. uh, I have few instructions for you. So there will be a test on Sunday. So please do not miss the test. If you have put your name correctly onto the Google form which was provided earlier, then that's okay. if you need any correction, please tell me in prior, because we will be making the certificates using those names you have put and the institution names which you have put in the Google form. So also try to solve the assignments which the teachers are, sorry, not the teachers, the resource persons are putting in the group. So try to solve them, try to go through them. I have already put the link to the videos. So with the due permission of Abha ma'am, I will share the link with the IIPT organizing team also, so that they can also have the video resources available. And thank you, one, and thank you all for these wonderful 5 days. So if directly, indirectly I have missed or maybe not given the due respect to anyone, please forgive me for that. And thank you everyone for joining. Now I may please request, this is my actual sincere request every day, to please turn on your cameras, because we never know who is sitting behind the screen. So I want to see your happy faces. The technology has made this available that throughout the India, people are here on one screen. So I want you to please
Take a
turn on your
picture.
cameras. And I'm
Take
going
a
to click the
picture.
picture. Yes, ma'am. I'm going to have the screenshots. Daily, we used to have the screenshots at the end, because this is the kind of respect I want to give to my participants as well. Those who are sitting behind the screen and continuously uh, watching, learning, trying to learn, trying to go through the topics being taught, guiding me through the messages that the voice is not clear or this and that. So I want to see all those participants with their happy faces, of course. So now the screen too. Thank you so much for turning your cameras on. Just a few shots. I need to just copy, paste, save. Just maybe one more minute and then we are done. So this is we can say, the boon of the technology, that we are here enjoying this 5 days workshop. And now we are at the conclusion with some takeaways, good memories, and plans for the future. Yes. So
I
I
will
have done my
upload the
job.
same. I will
Yes,
upload on
I
the
will share.
our IPT
Yes,
website.
I will share the
Yeah.
complete folder having the videos and the photos.
Yeah.
Okay, I will
Yeah.
put the
Yeah.
photos also in the same folder where the videos are. So I will share the drive
Yes.
link with you all.
Yes.
So thank you so much. With a promise to continue this journey further in some other way, with some other topics, with some other maybe resource person, with maybe with the same participants. I would like to take a leave, and I would like to have the permission so that we can end the meeting to all the dignitaries.
Yes.
Chalo, thank you,
Thank you so
ma'am.
much.
Yes,
Thank you,
thank you.
Bhakti
Thank you
madam,
so much, ma'am.
Patangal
Thank you,
ma'am.
ma'am. Thank you,
Thank
ma'am.
you.
Good
Thank
to
you
see
so
you.
much, madam.
Thank you.
Thank you so much.
Bhakti,
Thank
I have a request.
Yes, ma'am.
Please conduct one workshop for
Okay.
all school teachers who
Sure,
are
ma'am.
because the students are not understanding AI.
Yes.
It is very, very important, beta.
Yes.
I will request Abha also, but Rekha, yourself, Abha, take it as a war footing job.
Yes, ma'am. We previously tried,
Yes.
but anyhow, the things could not work out completely. But I'm sure with the blessings of Almighty, if the things go well, we will definitely plan one workshop for either school teachers or
Okay.
directly for the students.
Now we can conduct for school teachers first, so we will do that. We will do that for sure, ma'am.
It
And
is
thank
very
you
much
so much
needed
for
because
listening us.
how to use it responsibly
Yes.
Yeah.
is more important.
How to
Yeah.
use it responsibly.
Yeah.
Yeah.
We will do that.
Thank you so much.
Thank you, ma'am.
Thank you, madam. Thank you. It was
Ma'am,
pleasure
thank
to
you.
meet you, Dr. Kamal Singh. I hope
I
we
will
meet again
attend.
sometime.
I will
Yeah.
attend that workshop.
Yes.
I'm registering from now itself.
Yes.
The first participant
Yes.
is here. Thank you so much. Thank you.
Thank you, ma'am.
Thank you, sir.
Thank you, ma'am.
Thank you. So let's see.
Kudos to all the great ladies.
So thank you so much, everyone. Here I'm ending the link for today. Hope to see you all in some other platform on some other day. Thank you. Have a great evening ahead. Thank you.